Okay, so Airblast circuit breaker is used for interrupting heavy fault currents and for extinguishing the arc by the blast of air. Okay, so this air blast circuit breaker employs high pressure air blast for quenching the arc in between the contacts. Okay, so this air blast circuit breaker consists of compressed air at a pressure of 20 to 30 kg per centimeter square, which is employed as an arc quenching medium within the circuit breaker. So we can call this air blast circuit breaker as compressed air circuit breaker. A high pressure air blast will cool the arc and sweep away the ionized particles within the circuit breaker contacts. So you can see an image here. This is an air blast circuit breaker. Okay. So same image I am showing you here, another image, the same image, it is similar to this, okay? Both the images, this image as well as this image, both are same. I will explain it. Okay, so this air blast circuit breaker is suitable for operating at voltages of around 132 kilovolts and above. They can also be used within the voltage range of 11 kilovolts to 33 kilovolts for certain applications. Okay, so this air blast circuit breaker, requires auxiliary compressed air system. Okay, this air blast circuit breaker requires an auxiliary compressed air system. Okay, so this auxiliary compressed air system is connected to an air reservoir tank. This you can see here, this lower portion in here. This is the air reservoir tank. Okay, this is the air reservoir tank. Okay, so this air reservoir tank is connected to auxiliary compressed air system, which is not shown here in this image. Okay, so an auxiliary compressed air system is connected to this air reservoir tank. Okay, this is the air reservoir tank. Same tank I am showing you in this image also. This is the air reservoir tank. Okay, on this air reservoir tank, there are three hollow insulators, 1, 2, and 3. So these three are the hollow insulator. On this air reservoir tank, there are three hollow insulators. Okay, there are three hollow insulators. Okay, so on the top of each insulator column, okay, there is a double arc extinction chamber. Okay, on the top of this east insulator, there is a double arc extinction chamber. Okay, this is one chamber, this is one double arc extinction chamber. So here also you can see this is the double arc extinction chamber on this hollow insulator. Okay, so if you can observe in this image, okay, so there are current carrying parts. You see this, you can see connection for current. So these are the current carrying parts. Okay, so there are current carrying parts connected to arc extinction chamber. Okay, to this arc extinction chamber, current carrying parts are connected in series. Okay, these current carrying parts are in series to this arc extinction chamber. Okay, the assembly of entire arc extinction chamber is mounted on the insulators. Okay, as there exists large voltage between the conductors and air reservoirs. Okay, so in between this conductor and the air reservoir, there will be large voltage. Okay, so the main arc extinction phenomena is done in this double arc extinction chamber. Okay, so arc is struck within this double arc extinction chamber. Okay, and arc is interrupted within this double arc extinction chamber. Okay, so within these three double arc extinction chambers, arc is struck and arc is interrupted. Okay, so when contacts get separated, then an arc is struck between them. Okay, so I will show you this double arc extinction chamber. Above this double arc extinction chamber, resisting resistance switching unit is there. Okay, you know what is the need of resistance switching unit? So above this double arc extinction chamber, above this double arc extinction chamber, these are the okay resistance switching units. Okay, so this is also a resistance unit. This is also a resistance unit. Okay. So let us see this double arc extinction chamber. You can see here, this is the double arc extinction chamber. Okay, so this is the resistance switching unit. Okay, what you have seen here, the cylindrical units, and these are the vertical units which are shown horizontal here. So this cylindrical units, these two are the resistance units, okay. Now. Yeah, double arc extinction chamber. Let us discuss about it. So arc is struck within this chamber. This is the double arc extinction chamber. Okay, this chamber's inner view I am showing you here. This is the double arc extinction chamber. Okay, so this assembly of all these insulators, double arc extinction chambers are mounted on the insulators. Okay, arc is extinguished within this chamber. So whenever fault occurs, if you see here within this chamber, you can see a pair of fixed contacts. You can see fixed contact. This is one fixed contact. This is one fixed contact. This is one moving contact. This is one moving contact. Okay, you have a pair of fixed contacts and a pair of moving contacts. Okay, moving contact is this portion, this dark black lines you can see. This is the moving contact. This is also is the moving contact. Okay, and it is hollow inside. This moving contact is hollow inside, and these two are the fixed contacts. Okay. So when a compressed air enters into this double arc extinction chamber, okay, compressed air enters into the double arc extinction chamber, what will happen is the moving contact will move away from the fixed contact, and arc is struck between the moving contact and the fixed contact. Okay, since there are okay, so here moving contact will move away from the fixed contact. This side also moving contact will move away from the fixed contact. So within this chamber, two arcs will be struck. Okay. Similarly, since there are three double arc extinction chambers on each air reservoir, so total 6 arcs will struck. Okay. So each arc extinction chamber is consisting of since it is consisting of two fixed contacts and two moving contacts. In each extinction chamber, 2 arcs will start. Okay, 2 plus 2 plus 2, total 6 arcs will start. Okay, so moving contact, open position or closed position depends on the air pressure and spring pressure. Okay, if you observe in this double arc extinction chamber, the compression springs are there. So these are the compression springs. Okay, compression springs are there in this double arc extinction chamber. Okay, so initially under normal operating condition, due to the pressure exerted on the moving contact by this compression springs, the fixed moving contact will be in contact with the fixed contact under normal operating condition. You know, under normal operating condition, both the moving contact and fixed contacts will be in contact with each other. Okay, you already know that. Okay, so under normal operating condition, moving contact and fixed contact will be in contact with each other. So in double arc extinction chamber, the moving contact and fixed contact will be in contact with each other because of the pressure exerted by these compression springs. Okay. So the opening and closing of this moving contact will depend on the pressure exerted by this compression spring as well as the pressure within this chamber. Okay, air pressure within this chamber. Okay, so for the moving contacts to be in contact with the fixed contact, the compression spring pressure should be higher than the air pressure within this chamber. So whenever the air pressure within this chamber is less than the pressure exerted by this compression spring, okay, so spring pressure, okay, so when air pressure is less than spring pressure, then moving contact will be in contact with the fixed contact. Okay, in other words, when the spring pressure is more than the air pressure within this chamber, then moving contact will be in contact with the fixed contact. And the contacts will remain closed. Okay, they will remain in closed position. If the air pressure within this chamber becomes greater than the spring pressure, then the contacts within this chamber will open. Means moving contact will move away from the fixed contact. Okay, so the movement means the opening and closing of these contacts will depend on the air pressure as well as the spring pressure. Okay, so the operating mechanism will operate the operating rod when it gets pneumatic or electrical signal. Okay, so whenever fault occurs, okay, whenever fault occurs, there will be an operating mechanism which will operate this operating rod. So you can see here there is a rod here. Okay, this operating rod is operated by this pneumatic mechanism. Okay, so when a fault occurs, this pneumatic mechanism will operate this operating rod. Okay, so this operating rod is closing the valves of this air reservoir. Okay, this is the air reservoir. There are valves here below each hollow insulator. There are valves here. These valves are initially closed. Okay, under normal operating condition, these valves are initially closed. Okay, so whenever pneumatic mechanism gives signal to this operating rod will open these valves. Okay, this operating rod will open these valves of this air reservoir. In the air reservoir, the air is compressed. Okay, so whenever these valves open, what will happen? High pressure air will be sent into this double arc extinction chambers. Through these hollow insulators, high pressure air will enter into these double arc extinction chambers. That is it. High pressure air means compressed air. Okay, so it will rapidly enter into this double arc extinction chamber. As soon as this compressed air enters into this double arc extinction chamber, what will happen? The pressure exerted, air pressure within this chamber will become greater than the spring pressure, hence the moving contact will move away from the fixed contact. Okay, as the air enters into this arc extinction chamber, the pressure on the moving contact becomes more than the spring pressure and these contacts open. Okay, so the contacts travel through a short distance against the spring pressure and arc is struck between the contacts. At the end of the contact travel, okay, at the end of the contact travel, the port for outgoing air is closed. Okay, by the moving contact, and the entire arc extinction chamber is filled with high pressure air. Means outgoing port of outgoing air is closed, means this is the opening for air outlet. This is the air outlet. Okay, so on each double arc extinction chamber there will be air outlet. So as soon as moving contact opens, this air outlet will be closed. So pressure inside this chamber will build. Okay, both the air outlets. This is air outlet. This is also air outlet. Okay, so both will be closed. So pressure within the chamber will build up. Okay. Okay, this high pressure air is not allowed to go out because all the openings are closed. However, during arcing period, the air goes out through the openings and take away the ionized air of the arc. But this when this air, compressed air, when it touches the arc, it will take away the heat, ionized particles from the air, and in whichever path it can come out, it will try to come out. Okay, maybe it is through the hollow insulator. Okay. Since in the circuit breaker the contacts are separated under the action of air blast, the air blast ionized gases and arcing products with it and finally helps in the extinguishing of the air. As this air takes away the heat from the ionized particles, means from the arc, okay, so arc gets extinguished at some natural current zero. Even if it is not extinguished, there are chances of current chopping may be there, okay, because we are forcibly allowing compressed air to enter into this chamber, which will, with the high pressure, it will enter into this chamber and it will take away the heat from the arc. When it takes away the heat from the arc, there are chances for the current chopping. That's why an auxiliary contacts, you can say auxiliary contacts are there which are connected to this resistance unit, okay, resistance switching unit. So these resistance switching units Okay, so actually these resistance switching in this image, they are not visible. So these are the resistance switching units. If you carefully see these small sections here, these are the resistance switching units. Okay, so these resistance switching units will come in series. These switching unit will come in series, and they will be across the contacts. They will come in parallel to the contacts. You know what is meant by resistance switching. So due to resistance switching, we can avoid current choking. So in order to avoid current choking, these resistance units are used here. Okay. Okay, so this is a very frequent operation, hence the arcing time is very less in air blast circuit breaker. Okay, means the arc extinction will take place within a very short duration of time. Okay, so after the arc interruption, while closing the valve is turned so as to close connection between the hollow insulator and the air reservoir. Okay, as soon as arc is extinguished, the valves, these valves are to be closed. Okay, and this and the high pressure air, as soon as these valves are closed, high pressure air will come out through these hollow insulators. Okay, through this hollow insulator from this arc extinction chamber, it just comes out. So the valve lets the air from the hollow insulator into the atmosphere. Okay, so this which has taken the ionized particles from the air, or the compressed air which has taken the ionized particles from the arc, it will these valves will let this air from these hollow insulators into the atmosphere. As a result, the pressure of the air in the arc extinction chamber, what will happen? It will drop down to the atmospheric pressure. So as soon as the pressure in the arc extinction chamber has dropped down to the atmospheric pressure, what will happen? The pressure of the spring will be greater than the pressure of the air within this chamber, hence moving contact once again comes in contact with the fixed contact due to the spring pressure. Okay, so opening is fast because of air, because the air takes away the arc, means ionized particles of the arc within the negligible time. Okay, so the arc extinction will occur within one cycle itself. Okay, so this air blast circuit breaker is very fast in breaking the fault currents. Okay, so closing is also very fast. Opening is fast as well as closing of these valves. Okay, or closing of the moving contacts, we can say. Forget about the valve. Closing also very fast because pressure within the arc extinction chamber drops immediately. Okay, as the valve operates. Okay, as soon as this valve operates, these valves which are opened to allow the compressed air into these hollow insulators, as soon as these valves are closed, closing of the moving contacts also occurs very quickly. Okay, due to the spring pressure. Okay, so this is about the operation of the air blast circuit breaker. I hope you have understood. Okay, so there are some advantages of this air blast circuit breaker over oil circuit breaker. Okay, so when compared to oil circuit breaker, the advantages are it is cheaper and freely available. Okay, air is cheaper and freely available, and it can interrupt medium, okay, currents. Okay, of course, it can interrupt even low currents also, because we are allowing a blast of air, high pressure air within the contacts into the double arc extinction chamber. It can even interrupt low currents also. Okay, so it is cheapest and freely available arc interrupting medium, this air. Okay, it is chemically stable and okay, and it is inert. Okay, high speed operation is possible. There will not be any fire hazard. Okay, so fire hazards are eliminated. Short and consistent arcing time, therefore less burning of the contacts will be there. Okay, less maintenance is required. It is suitable for frequent operations. Okay, so in oil circuit breakers, you have to replace the oil. Okay, so immediately you can't use it again and again. Okay, so frequent operations can be performed by this air blast circuit breaker. Facility for high speed reclosing is possible. Okay, these are the advantages of air blast circuit breaker or oil circuit breaker. Okay, so disadvantages are an air compressed plant. has to be installed and maintained. Okay, compressed air must be available to fill the air reservoir. Okay, so compressed air must be filled in the air reservoir. So you need an air compressor plant. Okay, so it has to be installed and it has to be maintained. That is one of the disadvantage of air blast circuit breaker. Upon arc interruption, air blast circuit breaker produces high level noise. Okay, so when arc interruption occurs, air blast circuit breaker produces very high level noise. When air is discharged into the open atmosphere. Okay, so means as soon as arc is interrupted, arc interruption is over. Okay, so this high compressed air from the hollow insulators, it must be discharged into the atmosphere. Okay, so in residential areas, silencers need to be provided to reduce the noise level to an acceptable level. Okay, so we need to install silencers in residential areas if this sort of air blast circuit breakers are located nearer the residential areas. Okay, so there is problem of current chopping. That's why we are connecting the resistance unit here, and the problem of there is a problem of restriking of the voltage in this case. Okay. Okay, so you already know if current chopping occurs, there are chances for the restriking of the arc. Okay, so there is low voltage, even my laptop charging is over. Okay, there are two types of air blast circuit breakers. So, according to the type of flow blast of air, two types are there. One is cross blast type, another one is axial blast type. Okay, cross blast type and axial blast type. In cross blast type air blast circuit breaker, the blasting of the air is directed at a right angle to the arc path. So if you see here, this is the moving contact, this is the fixed contact, an arc is struck between these two contacts. This blue arrow mark shows the direction of air. Okay, so the blast of air is directed right angle to the arc path. So if blast of air is directed right angle to the arc path, then such air blast circuit breakers are known as cross blast air circuit breakers or air blast circuit breakers. Okay, similarly, next type is axial blast type. Okay, so in axial blast type, the blast of air is done directly along the path of arc. Okay, so blast of air you can see along the path of arc. Blast of air is the direction. Blue arrow marks represents the direction of air. Okay, in the lower case also you can see the air direction is along the path of arc. Okay, so the axial blast type can be of two types: single blast type as well as the radial blast type. Okay, so in single blast type, the blast of air is done directly along the path of arc. Okay, so blast of air is directly along the path of arc. In the case of radial blast type, double blast arrangement will be there, in which air blast flows radially in between the contacts. Okay, air blast flows radially in between the contacts. Okay, so you can see one more image. So axial blast and cross blast. Direction of air. This red arrow marks in this image represents direction of air. Blast of air. Blast air direction. Okay, so let us discuss cross blast air circuit breaker. Okay. So cross blast air circuit breaker. Okay. So just now we have discussed in the cross blast air circuit breaker, the air will be directed. 1 minute. Okay. So the air blast will be directed at right angle to the arc. So you can see here, this is the arc, the red color one is the arc. The airflow is perpendicular to the to this arc. Okay. So air reservoir filled with compressed air. Just now we have seen. This is a air blast type circuit breaker, isn't it? So the air reservoir filled with compressed air is connected to the arc extinction chamber through the hollow insulators that you already know. Okay, so the arc extinction chamber contains fixed and moving contacts. Okay, so you already know in the arc extinction chamber there will be fixed contact and moving contact. Okay, arc in the case of cross blast type air blast circuit breaker, we are providing arc splitters here. You can see arc splitters. These black lines are the arc splitters, and baffles are provided. So baffles act as arc runners or arc horns. Okay, so this blue color lines, if you see, these are the baffles. Okay, so arc splitters are used to, you know what is the purpose of arc splitter? In order to use they are used to increase the length of the arc, whereas baffles are used to provide necessary cooling of the arc. Okay. So when the moving contacts are withdrawn due to the fault in the system, okay. So when the moving contact moves away from the fixed contact due to the fault in the system, arc is struck between these two contacts, okay, between the moving contact and the fixed contact. A high pressure air which is coming at right angle to the arc will force the arc into the arc splitters. Okay, arc splitters are nothing but arc tubes. Okay, okay, and the arc splitters will increase the length of the arc, okay, and since resistance is directly proportional to the length, okay, since resistance is directly proportional to the length, hence if the length of the arc increases, resistance also increases, means direct strength of the arc is increasing. Okay, so the increment in the length of the arc will increase the direct strength of the path in which the arc is moving, okay, and finally it will interrupt the flow of the current. Okay, hence arc is extinguished. Okay, so since the blast pressure is independent of the value of fault current, so it is very efficient at low currents also. Okay, so this method of arc interruption is efficient even at low currents. Okay, so procedure is almost same which we have already discussed in the case of air brake circuit breakers, is almost same. Okay, so next one is axial blast type air blast circuit breaker. Okay, so axial blast type, it can be single blast or radial blast. Okay, so this is the common type of air blast type circuit breaker employed for axial flow of air blast for extinction of the arc. Okay, so the arcing chamber is connected to the air reservoir with an air valve. You already know that. Okay, fixed contact and the moving contacts. So, okay, so this is our arcing chamber. Let us assume. So this is our arcing chamber which is connected to the air reservoir tank. Okay, through a valve. There will be a valve here which you have already seen. Oh, it is far away. Okay, so arcing chamber is connected to the air reservoir through a valve. Here valve will be there. Okay, so that's what I am talking. Okay, so there is no enough charging in my laptop. I hope I will complete this topic quickly. So this arc chamber is connected to air reservoir with an air valve. Okay. So the fixed contact and the moving contacts are held in closed position initially. The fixed contact and moving contact are held in closed position with the help of a piston. Okay, there is a piston here in this type of axial type of air blast circuit breaker, which will okay, so this piston, and there are springs. Spring will compression springs are also there. So these will keep this moving contact in contact with the fixed contact. So the air valve remains closed until under normal condition. This air valve, This is the air valve that is remains closed under normal operating condition, but it will open automatically by the tripping impulse when an fault occurs in the system. Okay, so whenever fault occurs, relay will detect the fault and it will give signal to the circuit breaker. Okay, as soon as circuit breaker receives signal from the relay, automatically this valve will open. Okay, So a series isolator, you can see a series isolator here. This is the series isolator. Is also connected in the actual blast stack to give sufficient voltage clearance after the braking operation. Okay, in order to give sufficient voltage clearance after the braking operation, a series isolator is also connected. When any fault occurs in the system, tripping impulse. Okay, so the tripping impulse will cause air valve to open automatically, and it connects air reservoir to the air extinction chamber. This is our air extinction chamber. Okay, so the high pressure compressed air now moves into the air extinction chamber. Here what will happen, the pressure exerted by this piston and spring, which was high when compared to air pressure within this chamber earlier, now what will happen, the pressure exerted by this air will be more than this pressure exerted by the piston and the spring, compression spring. Therefore moving contact moves away from the fixed contact. Okay, so as the air pressure becomes more than the spring pressure, what will happen? Moving contact will separate and arc will be struck between the contacts. Okay, the pressure of the air blast is axial to the arc. Okay, so this air blast which is entering here, it will be, that pressure will be axial to the arc and it will decrease the area of cross section of the arc. So this axial air which is blown into this chamber actually will take away the heat. Okay, and it will decrease the cross section of the arc. Okay, as resistance is inversely proportional to area. Okay, when area of cross section decreases, resistance will increase. Hence the dielectric strength of the path will increase. As the current is flowing through the arc, but due to the increase in resistance, current flow will stop. Okay, through the arc, because the air is taking away the ionized particles. Okay, hence arc is extinguished. Okay, so in these circuit breakers, contact separation required for interruption is very small. Okay, this separation is very small. The distance between these two contacts when they are separated is very small. It is around 1.75 centimeters. With such a small gap may constitute inadequate clearance of for normal surface. Therefore, this isolating switch. Okay, so there is an isolating switch which is provided here. Okay, incorporated in this part of circuit breaker, when open immediately after fault interruption, provide necessary clearance for the insulation. Okay, so since the distance between contacts is very small, therefore in order to provide necessary clearance for insulation, there will be an isolating switch provided. Okay, so there are some advantages. High speed operation is achieved, fire risk will not be there. Okay, growth of dielectric strength is very fast. Okay, arcing time is very small. It provides frequent operation due to lesser arcing energy. Okay, so this circuit breaker requires less maintenance. These are all the advantages. Okay, so disadvantage is it is necessary to have a compressor with sufficient capacity of high pressure air. Okay, there is possibility of air leakage at pipe fitting. Okay, it is very sensitive to restriking voltage. Maintenance of compressor is required. Okay, so